Hello, everyone. Welcome to the March 2025 edition of PDH Hour with Glenn. I'm your host, Glenn Tepfer, and this week we're going to be continuing our discussion on Destructs. Everything you want to know about Destructs, part two. I think Destructs are an important topic in the industry. Couple reminders before we get started here. You can find our past webinars. On our website, cqasolutions.com. And the other reminder, unfortunately, we can only award PDH credit hours for those who complete and attend the live webinar. We have no way of tracking it otherwise. And we've been getting numerous requests, but that's the only way to be fair to those who attend. So I'll start with the outline here, going over part one that we did a month ago and moving into part two. What are destructs? Basically, I discussed that in part one, that they're testing the integrity of the seam. You're looking at your strength, peel incursion, and elongation of shear. Make sure they meet the project requirements. There's two types of destructive seam samples. End coupons and the interval samples. We'll get into those a little bit. I'm not going to go into the end coupons a whole lot in this presentation. Then we got into project requirements. The good foundation for any project is having good project requirements that allow the CQA, allow the installer, allow the certifying engineer to do their job and ensure quality. And then we talked a little bit about implementation of project requirements, basically looking more at the construction document side of things, the engineering side of things. We're going to continue there today, getting into more of the field, looking at the installer's field testing. And then as part of that, I'm going to briefly talk about peel incursion, how you measure that. I thought that would be a good addition when I was going through preparing for part two. We'll look at destruct logs, some of the data that I like to make sure is on the logs, and then a brief discussion of why a thorough review of laboratory results is critical. Dealing with failures, big topic. We see a lot of mind-boggling things there. My recommendations overall on the different aspects of destructs. I'll give you a brief highlight of what the next webinar is going to be, and then we'll have question and answers. So use your question feature on your browser, and I'll get to as many questions as I can at the end. I'm going to start with a review, probably 10-minute, 15-minute review here of part one, just so that we can get everybody who's catching this one now caught up, and it'll help lead into everything, keep the discussion fresh in everyone's mind as we continue today. So I talked about the destructs, measuring the integrity really in the United States anyway. We take destructs and we look at the peel incursion, peel strength, shear strength, and percent elongation. And you can see this table here is from GRI GM19A, which currently, governs several, I think 3 geomembranes. HDP is one of them. And since 60 mil is common in the industry, the age-old question, it's why are you cutting a hole in the geomembrane for a destructive sample? And, you have a fusion wedge welded seam that requires, say, 91 pounds per inch, and you're replacing it with an extrusion repair that only requires 78 pounds per inch, and is definitely, as viewed by almost everybody in the industry, an inferior weld. And the short answer, I guess, to that is we need to keep, installers accountable, verify our integrity somehow, and right now we just don't have a better method of doing it, unfortunately. But there are ways, and I'll get into ways, where we can minimize the impact it has on the overall quality. We can reduce the amount of holes in the geomembrane and strategically look at the sampling. So a few warnings, main warning about destructive testing. It doesn't consider any potential damages to the geomembrane through the welding process. You may catch, if your machine is scoring the geomembrane parallel to the seam, it may fail shear. If it's deep enough, it'll fail shear for sure. So it may catch a few of those things, but one of the biggest things we see in the industry is this overheating, and overheating isn't part of the evaluation process. Some of us have been talking about this issue for years, and it was just a part of a panel discussion at the Geotechnical Frontiers, a pretty lively discussion, but everybody's realizing that we need to address this issue. And the trend in the US here's a photograph showing, a severely overheated seam. And, this was a sample that the installer said, go ahead, take it. It's going to pass peel and shear. And it did, it passes peel and shear, but, the liner is going to have issues in the future, especially if there's ever any stress. So, it's not really doing anybody any good to have it like this. But right now, our hands on the industry are tied. But I've talked about that in other webinars in the past, so I'm not going to dwell on it too much here. So this is a fusion sample that's overheated. Here's an extrusion sample that's overheated. Again, you can see kind of the 90-degree bend, it's overheated. It's sucking the material up into the weld as it's being welded, and just going to lead to brittleness and issues in the future, and something that we need to figure out how to address. And the whole purpose of the overheating is so that you pass this destructive testing. So here's an example when I'm talking about a few of the terms. This is a dual track wedge weld. You have your weld where the wedge goes through and melts the polymer, and then the nip rollers come through and put the pressure on that joins it together. You get squeeze out, and then in that squeeze out zone too, you're also having a heat affected zone where, the heat's impacting more than just the seam. You're having your air channel on the dual track, and then on the other side, basically a mirror image when the weld's done properly. When we're talking about the overheated seam, you can see significantly reduced thickness of the weld, sharp edge, reduced air channel, excessive squeeze out. And those are things that are going to cause problems. It's going to be an increased likelihood of crystallinity in the future, stress cracking, likelihood is significantly increased. So what are the alternatives to destructive testing? In the past webinar, I spent more time on this, but there really are no current alternatives to the destructive sampling. Should other things be added? I think that's where we're headed in the industry, is we need to look at it a little bit more, maybe consider the thickness reduction like is done in Germany. But right now, we have a lot of people who mistakenly think electrical leak locations can replace destructive samples, and the two don't really have anything to do with each other. That's totally wrong. Data recorders, same thing. People are trying to replace destructs with data recorders, but if you listen to my past webinars, the more I found out about data recorders, the more I find out it seems like the data is more and more meaningless for the most part. There are certain things you can gain out of it, but definitely not enough to make decisions on destructive sampling and is the seam good or bad. End coupons aren't a replacement, but they should be considered an alternative that can be used as an aid. Not an alternative, but as something that can be used as an aid. And then, like I've seen plenty of failures happen even when end coupons are taken and passed. So not foolproof, and any of these other things aren't as well. Then I briefly discussed why I believe repairs should be subject to destructive testing. If you look at, I went through 25 projects and came up with, we average on 22, 23 foot wide sheet, we average 300 to 500 lineal foot of extrusion welding just in repairs, sometimes more, sometimes less, but that's a pretty good average. So you look at a 10-acre project, you have a mile of extrusion seam out there on the project, and nobody's testing that. It doesn't make sense to me when we know it's an inferior weld. It's heavily labor intensive, heavily dependent on the conditions, the operators doing their work, but yet we kind of turn a blind eye to it, and I think that's unfortunate. Um, and another reason why I think so is, I did a study several years ago and looked at some of our projects, and we found that the failure rates went as high as 60% sometimes on the extrusion samples, and that's on repairs. It's not just on an extrusion seam that's used to join two panels together, but on the repairs, and that's a significant failure rate. Then I talked about seam interfaces. Basically, your smooth, textured interfaces. And a lot of times these are overlooked and not included in the destructive sampling protocols. And, there's a significant amount of seam footage that adds up, especially on the projects where you're using the smooth, smooth welding edge material with a textured remainder of the sheet. Um, so you end up, with the different interfaces, your seams in the machine direction are all going to be smooth, but then you run into tie-ins. They'll be textured, or textured smooth. So you run into the different interfaces, and that poses different challenges on welding. Yet a lot of times these seams are overlooked and their footage adds up just like extrusion repair footage adds up. And then just like extrusion repair footage, anytime a textured seam is involved, the failure rate goes up. So we see significant failure rates going up on texture, and any textured interface. You have your smooth, maybe up to 7% on one of the projects, but you can see consistently above 10% on a lot of these where textured interface is involved. And then that also applies to the tracking, and I'll get into that a little bit more here in the future. But you have a destruct on a textured butt seam that's 22 foot long. It fails, and then it's tracked onto the smooth seams, and it passes. And that happened in all 8 cases on this project. I looked back in 2019. Failure rate calculations, data in is data out's only as good as the data going in, and there's a whole lot of different ways of looking at the data. And this table just illustrated, in the field, you include the field failures, we're at 8%. Laboratories, you get laboratories saying, hey, our fusion sampling's only 2%, 1%, our failure rates are great in the industry for the wedge, but they're not getting all these field samples. So there's already a bias when they're saying that. So another way I look at it sometimes in the field when I'm analyzing the data is I'm looking at, what's our failure distance? If I start seeing where failures are propagating themselves and going for longer distances, and I might be inclined to slow down, reduce the testing frequency, or increase, I guess you'd say, the frequency. So instead of the 500 or 1,000, I'll cut it in half because I'm seeing that there's an issue with that machine. And that's something that really isn't discussed in any of these other alternative recommendations like GRI 14, GRI GM20. Nothing really talks about the failures, and looking at those, you're just looking at how many of the original samples pass and fail, and I think this is a big thing that's overlooked there as well. Then we talked about implementation of the project requirements, and I started really with the engineering. A lot of times, a lot of engineers we've worked with, the interval sampling really is misunderstood and basically meaningless. If you're just wheeling off 500 feet, marking a destructive sample, you're cutting a hole in the liner that's, in most cases, probably not telling you anything you really don't already know. The seam's probably going to be good in most of those cases. And I'll show you a few examples of the different things we've seen here throughout this presentation. But my philosophy is use the destructive samples. If we're going to cut a hole in the liner, it should be strategically placed so that we learn the most that we can. without compromising the liner integrity any more than it already is being. Um, Whoops, get happy fingers here again. Too much coffee. So here is trial weld, or not trial weld, seaming records that went along with this with discussion last part one, and these are just follow with the diagrams that are going to follow, kind of mocked up as-built sketches here. But the color of the seaming, the welding team operator and welding machine, those will play into the same colors on the as-builts that are coming up. There was a couple pages of them. And so the first one, this is how we used to see it. I don't see this very much. We come across it occasionally in our auditing of projects, but it used to be just wheel off 500 feet on the geomembrane. Start on the first seam, wheel off 500. That's where you put a destruct. And, that's how I started when it was, early in my career, and I'd find little marks there on the geomembrane. Well, the installer knew where the G-structs were going to be because they wheeled them off ahead of time too. So they'd have a mark there so their operator can make sure that they had a nice seam and everything passed right there, which, it's part of the cat and mouse game, I guess, between installer and CQA owner. There's a lot of cat and mouse that goes on, and I'll be discussing that as we go through this as well. But what I wanted to show here on this, the blue are all the destruct locations doing it this way. The different colors are the 500-foot intervals. Just for this, we're using the 1 per 500 that's still commonly used in the industry. But you can see in doing it this way, we actually suspect areas. We hit 0 suspect areas. And what I mean by suspect areas really are areas where there's burnouts or something else that would cause you to question the integrity of the seam. So none of these areas were addressed. There's burnout here, burnouts here, and burnout on this seam. None of those are addressed by the destructive sampling. We missed one machine operator combination altogether. Textured interfaces, which are harder to weld and proven to fail more. We hit 0 of those out of the 3 combinations. And then we created 7 extra holes in the geomembrane that probably all passed and didn't tell us anything that we really wanted to know. Then we went to 1 per 500 feet per operator and machine, and that's really what you still see in the industry most of the time now is 1 per 500 feet. Maybe it's 1,000, whatever the specs are, but that's going to result in your destruct locations with the red stars on this diagram. The way the seaming was done, it progresses, and it's going to result in the samples taken at the end of the 500-foot interval. So again, it could be middle of the seam. You're cutting extra holes in the geomembrane, and with the exception of maybe the one on panel 4, panel 3, you're not gaining a lot of extra knowledge. In this case, we did hit that one suspect area on panel 4, panel 3. We didn't miss any machine and operator combinations. Our textured, we actually did sample one, but that was kind of just a fluke the way it worked out. There was no guarantee we were going to get any. And then extra holes, we cut them down to 4, and that's just the way it worked out in this case too. It still could have been 7 had the panel layout been different. So what I like to do is what I say using the suspect areas and the intervals. So you look at your same 500-foot interval and you look, is there a suspect area? Is there something in there that I'm concerned with? Like in this case, I put a destruct right after the burnout on panel 3, panel 1. So in that case, I'm testing to see if there was any impact from the burnout on the rest of the seam. And, if there's not, then I put the sample at the end of the seam or somewhere where there's already going to be a hole. So by doing this, I addressed all suspect areas. I was able to test all 3 different textured interfaces with the different 3 welding machines. No extra holes were created. They were all, somewhere there was already going to be a repair, and no operators or machines were missed. I think it's one of the best all-around approaches you can have if we're going to be taking samples. And then I did a summary on it. And again, here's the suspect areas. I probably should have circled them on previous slides. Your textured interfaces, The flexible allowed us to catch all three of the suspect areas, all three of the textured, and we had zero extra holes. Um, so that pretty much sums up what I went over in part one. So now we're going to start our new adventure today, part two. Um, we'll start with a CQA, CQC. This is um, oh, a diagram here just showing, different goals, and not everybody is on the same page, unfortunately. And, I think that's one of the challenges in the industry is how do we get everybody on the same page? But as an example, here's a quote from a site owner. This is a cap. We don't need the B plus effort of a cell. I'm okay with a C minus. And, I don't understand that. Well, first of all, it was being said to me, so I'm like, I don't understand the B plus. I try and give everybody an A plus job when I'm out there, but um, it's just a lesser quality because people deem it as a cap isn't as critical, but that's not the case, especially on certain types of landfills and such. And then, to complement that, similarly, the certifying engineer, you're told, well, I'm being pushed to the limits of my comfort by the owner in certifying this project. And you just kind of want to throw your hands up like, why are we doing this in this industry at this day and age? We can do good projects. It just takes everybody being on the same page and ultimately doing it right, and doing it right the first time is the best alternative for everybody in the industry versus finding out you have a problem 5 years down the road. So there's many variables that impact your CQA, CQC teams. Knowledge of project requirements is a big one. Let's face it, there's a lack of education in the industry. It's a word of mouth trade. And unfortunately, um, not everybody knows the same thing. So that's one of the reasons why I'm doing these webinars, is to try and share with you what I've learned over the years. Same with experience. A lot of people don't have that experience, and you'd be surprised. There's people that are doing things, they've been doing it 25, 30 years in the industry, and they're still doing it wrong or not to the best practices that can be done because they weren't taught differently. On the cruise, peer pressure is a big one. And, incentives on liner crews is a big one. Both your bonuses for not having destructive seam failures for your operators, as well as your peer pressure from other people on the team, the air test people, repair people, to leave things go. Because you're all working together, the QC is going to be stuck with that crew for the whole rest of the year, and if he gets them angry, his life's miserable on the road. And we've seen that happen. Um, so marking samples. Um, yeah, I can't stress enough the timely marking of samples. Samples should be marked as soon as possible. They should be cut as soon as possible and tested as soon as possible. Ultimately, if there's any negative feedback, you want that feedback right away so you can get it corrected and move on with a better quality job before you have hundreds and thousands of feet or miles of bad seam out there. And with a good crew, um, good installer, usually they'll get welding, they'll get their air testing going, and you can follow behind them marking samples. You can get samples out each day. I like to wait until after the non-destructive testing is completed before I mark samples. That keeps everybody honest, gives you the best use of data. You can use everything available to you. And then, locations, you need to follow whatever sampling strategy is approved for your project. If it's 1 per 500, 1 per 1,000, follow that, but do it wisely. Avoid critical and sensitive areas, avoid flow lines, sumps, high stress areas. There's a picture of a sump, and we've seen it on our audits. Experienced people will know to avoid these places, but inexperienced people, they'll mark a destruct right in the middle of the sump, and then the engineer's coming back and asking why they did that. Well, you told me to mark them every 500 feet, and that's what I did. And so it's, you know, lack of knowledge that leads to something that can be detrimental in the project. Excuse me. And I mentioned the flexibility, selecting locations versus a grid. I left this blue text. I put it in here instead of just telling you like normally I'll share some of my thoughts, but I really believe in my career, I've caught miles of bad seam because of using flexibility and destructs. If I just wheeled off destructs every 500 feet, um, there'd be a lot more bad seam out there. I'm sure of it. I'm pretty sure that um, some of these things I'm going to mention here too, I don't know how many of you know, but I led the zero leak CQA effort at Palo Verde for 492, 93 acres of dual line geosynthetics. And it wouldn't have been zero leaks if we didn't have that flexibility with the destructs. If we just wheeled them off and marked them, we wouldn't have caught things. And some of these examples are these random striations. This is a good example. We were working night shift, but I'd go out in the daylight before the shift started the next night and walk the seams and mark my samples so we could get them cut because it was better to see the seams in the daylight. And there were three machines out there, three wedge welding machines. Two of them caused striations randomly on the geomembrane, and I picked up on that. I caught it, and I took samples on them to see what they were. And on the one machine, it resulted in low pound failures. Well, the installer figured out what I was doing, and I'd see the striations, and then I'd see that the overlap flap had been trimmed off, so I couldn't take a destructive sample there, which, okay, fine. You know, then what we're going to do is we're going to have you repair them here because I can't take a sample, and usually that's in the spec. So I don't care if we're not cutting extra holes in the liner. If something's bad, let's just get it fixed. Sometimes it may warrant getting cut out, depending on the circumstance. But, it's just an example there where if we all work together, the installer never told me what the issue was. I'm sure they knew what it was. They figured it out, but they don't share that knowledge. And that really hurts us as an industry. They don't want somebody to pick up on what can be used against them. But at the same time, if you share that knowledge, we can all learn together, learn what to look for. And it's frustrating, but that's a cat and mouse game again. Same thing with dirt, tape, paint, if it's not seen from above, a lot of installers aren't going to fix it. And then another one, we had speed wedges on a project where the installer brought out these wedges, it'd take maybe an hour to weld a 500-foot seam somewhere in that ballpark, and it would cut it in half with the speed wedges. And I was marking the destructs, we got the lunch time or whatever. I started marking my samples, and there were no areas that looked bad, so I put them at the beginning of the seam. Well, it turns out that first 7 foot of seam was bad on the speed wedges. It couldn't get up to speed and heat in that 7 foot time. So, because I was marking them promptly, we found that out that same night when they did their field testing. And by the end of the shift, the installer stopped using them. The remainder of the shift, um, they used them the remainder of the shift, but they pulled an extra 10 feet of geomembrane beyond what they needed for the intersections, and they would weld it and then cut it off, and they used that material for repairs. But the following day, they didn't use them anymore. But if we were waiting days to get our sampling done, they would have had miles of seam done out there. That was all, poor in those areas, and we'd have ended up with a lot more repairs. So then I mentioned new holes, creating new holes. I think that's a big one in the industry. In my career, I think using this flexibility, I'm sure I've had hundreds, maybe even thousands of new holes that have been avoided since I started using the flexibility method. And a lot of times, I try and talk it over with engineers, get them convinced that that's what needs to be done on their project. And usually they'll agree if they have confidence in you, it's how much confidence they have in you, how much confidence they have in regulators sometimes too, because everybody wants to see their project get certified and approved. And I mentioned it's also better suited to avoid the critical areas. So some of the things, look for, utilize all the data when you're marking your samples, look at power failures, seam appearance, what did the non-destructive tests look like? Failing trial welds. If I have a failing trial weld, I like to mark a sample a lot of times on that first seam they do somewhere in the beginning. And then if they fail a trial weld right after lunch or second part of a shift, I'll go back and put a sample on that last part of the seam done right before the shift. And you find problems that way. Sometimes you don't, but at least you know that you've made an effort to check. Failing end coupons, visual observations, anything you see during seaming, but you need to make sure that you write those locations down. And then you can use data from the data recorders too. Again, if you've listened to any of my prior webinars, I'm not really a fan of the data recording, at least at this point in time. There are a few things I think you can glean from it, like making sure that people aren't turning down the heat ahead of end coupons, but to make any type of saying whether the seam's good or bad, any type of correlation, I don't think it can be done at this point. And I'm more and more skeptical of it when I talk to people in the industry. Marking samples, again, it's a balance. If you got a critical area, do you really want to cut a sample? I think there's other practices that can be done, maybe redo a seam if you can redo it without compromising the integrity. And then always on your destructive log, record locations when marked. Don't wait or you'll get confused, things will get missed. And then record your notes on the seaming or the reasoning, especially when you have your suspect causes. So cutting samples and securing, you've marked them, now they're getting cut. Again, they need to be cut in a timely manner, not at the end of the project. You need to obtain the laboratory sample when it is cut, and that's something that a lot of people don't realize. We have a chain of custody, we fill it out. And whenever we get our samples, a lot of times we get them back from the installer. It may be later that shift, it might be the next day. But what happens with those samples from the time they're cut out till they get in your possession, you know, um, there's a lot of installers, that, we have a lot of former installation people come and work for us from time to time as CQA, and some that have retired, and you talk to them, and rewelding of samples and relabeling of destructive samples, it's way more common than you'd think. I stopped that years ago when I caught a guy that was rewelding and renumbering because the little marks I put on my sample weren't there, even though he was able to forge my handwriting pretty good. I probably should have had him write some checks from somebody, but yeah, he was good, but I stopped that. And you think about it, your samples in any other industry, you sample groundwater, sample soil, contaminated soil. You get your samples, you fill out a chain of custody, they stay in your possession, you sign off on them for the person in the next possession that gets them, and it's until the samples get to the lab and are sampled that chain of custody form accompanies them. But in the geosynthetics industry, we cut them out and leave them with the installer for nights, days, and you get them back. Are you sure they're your sample or not? The best thing you can do is make sure you get them right away. And, that's another thing that isn't accounted for in these failure rates that people say are really low on projects, is things like that. Shipping samples, again, they should be shipped as soon as possible, not until field testing is performed, when field testing is being performed. I think there's times where you need to get them shipped out, but you can let the lab know, hey, don't test this when it failed. Get the field testing done afterward if it's critical. You got rain coming, something like that. But for the most part, you want to wait until you get your field results and ship them. But, you don't want the installer to procrastinate forever either. You want to find problems as soon as you can so that they can get fixed. Again, put the date shipped on the destruct log, and that just helps you keep track of all your data in one place so you can manage it. So now I'm going to move on to the installer's field testing. And this is one of my kind of pet peeves in the industry here. Well, I got many, but I can go off at any given moment. But like that big bird on whatever that Angry Bird thing is, and blow up. But I get told, I've heard this a lot of times. It's double jeopardy. If we test our samples, it's double jeopardy. We got double the chance of failing. So what? Isn't your sample supposed to be good? I mean, the whole purpose is to catch stuff that's bad. So we're better off to have it where you catch it. If it's bad, yeah, it slows down your production some. Maybe you can't give your welders incentives like you'd like to give them, but I mean, at the end of the day, it's really about quality, not about your installer or your operator pad in his wallet anymore. It's about the owner's wallet and what's going to happen in the future. Um, often we get QCs that don't know what the required values even are. And you can't always blame them. It's not communicated to them a lot of times. And then they're hopping from project to project. Somebody's got to really make sure that they know what's required, what they need to look for. A lot of times they're not even trained to know what peel incursion is. They're not even going to examine the coupons for peel incursion, but really, for the most part, you don't need them to calculate out peel incursion, even if it's their field test. If they can eyeball it and ballpark it to the nearest 5%, they should be able to screen out most of the failures. Um, and your testing speed plays a big impact on your results. And, it's just many installers are willing to gamble. We've seen it, they're willing to gamble that the lab sample is going to pass, even if a field failure is observed. And they want you to submit it. And they'll tell me, well, you submit it anyway, but I won't submit it. If it failed, it failed. We got to track it. Installers field testing, some other things that really impact, their values. You got to keep in mind. Usually the conditions aren't going to meet the requirements of the ASTM, which a lot of times isn't a big deal. If you start, it's too cold, you're going to get higher values, too hot. So you got to, keep track of it. Too hot's going to give you lower values. Your shear elongation may fail, but you definitely need to keep it in mind. Your tensiometer accuracy, is it calibrated? How's it been handling? Just because it has a calibration certificate doesn't mean it's operating properly. Keep an eye on it. Sometimes you'll hear screeching and the thing sounds like, well, I've seen them catch on fire too, but that's a whole other issue. Um, but um, proper machine settings on the tensiometer can give you erroneous results. Not many people realize this, but the double coupon tester that you see that's popular in the industry, I've watched it numerous times where one coupon's finished, and it has a value. Maybe it's like 80, 89 or something on the peel strength, and um, the other coupon below it breaks. And it has a sharp break. You hear the break, and that pounds jumps up 2, 3, 4 pounds sometimes. So, what does that mean? I don't know what that means. Any engineer I've ever asked, they just say, well, go with the end result. Well, I don't agree with that, but I don't know how you get the warm and fuzzy feeling with all that. Um, and then coupon size. As most of you are aware, you have a wider coupon, you're going to have a higher value, but that higher value, if you divide it back into the 1 inch wide sample, may end up failing, and vice versa with thin sample. It could be below pounds, but yet if you calculate it out, it could pass. So it would be higher, but that's why it's important that they cut the coupons to the required size. Then I threw this in here just from the ASTM. This is really if you're following the ASTM for your peel separation. There's that part in here that I colored red or whatever color it's showing up on your screen. It looks orange on mine, but it was red on the PowerPoint. But anywhere across the width of the seam, if the peel goes across that width, it's 100% peel, and most people aren't going to realize that. Most QCs aren't going to realize that in the field. A lot of CQA people don't even realize that, but it's something to keep in mind. And I threw in this example of it here. A lot of QCs aren't going to realize this. If you have this area peel incursion here, your seam is really the area between the two hashed lines here. That's where your nip rollers had the pressure. So that's your area seam. You take your area of peel incursion. I usually measure it with a scale and the 60th scale and divide it out. But um, you can see here it peeled and it calculates out to like 9%. So you round it as 10%. But because it peeled across this whole width, it's automatically 100%. So that's something to keep in mind if you're ever dealing with peel incursion and having to make decisions based on that. And I'll just go into a few examples here. I thought it would be good to include as part of the destruct discussion. How do you determine the area of peel incursion? You take your area basically and you try and divide it up into geometric shapes. I'll try and do this while I'm holding a scale, and find points that I can measure. Take the measurements, divide it up into rectangles and triangles is the easiest thing. It shouldn't go beyond the squeeze out, or into the squeeze out. In this case, you can see part of the triangle is there, and I use that, try and account for some of these other areas. It's just an eyeball. You're rounding to the nearest 5%. You're trying to get a rough idea. So in this case, maybe the triangle went a little bit long. You just try and do the best you can. And if it's borderline, then you got to make a decision, if it's 25% or 30%, but it's few and far between that they're right on the line like that. Most of them are going to be obvious one way or another. But anyway, you take your area of your weld, your width, and your length, and then you take your area peel and divide them out. In the field, what I like to do is a quick down and dirty. You can look at your impressions on the nip roller, some of the wedges anyway, leave good impressions that you can actually see and count. So you can take your total number, then count up the number that's in the area peel, divide it out, and it gives you a pretty good ballpark of what that peel incursion actually is. Good enough for a field decision anyways. If you look at extrusion, one of the challenges with extrusion, well, there's a couple of them. One is that your weld, per the ASTM and the guidelines, really is that you only count what is equivalent to the sheet thickness of the extrusion weld. So your extrusion weld, if it's a 40 mil sheet, you should have 40 mil of extrudate. And if it's any less than that, it's not counted. So that's where you kind of cut off your boundary there. And the other side you can see isn't as wide, so you got to use your average, figure out your area. And then same thing, you look at your area peel, use geometric shapes to the best of your ability with a scale or whatever in the field. I've seen where they suggest you can photocopy them, but I never found that to be successful because the coupons just won't lay flat usually. And in that case, you had your 4 different geometric shapes. You get your total area. In this case, 390. You have your 2 sides, 24 and 20. So it was an average width of 22. Multiply it by the 60, which is an inch and 60ths. Gives you your seam area. Divide your peel area by your seam area, and you 29.6 or rounds to 30%. So it's really just a quick down and dirty of how you do the peel incursion if you ever have to do it in the field. So a couple quick things about destruct logs here. I gave a sample one here. A lot of the information we collect, we do it by different layers, secondary and primary, but we get your sample, seam ID, your weld type, location's critical, your welder information. And then, like I said, I like to have your date marked, date sampled. A lot of times we'll have a column for date shipped as well, but sometimes our clients don't want that, so we'll write it in the notes or write it in a different log. And then your test results, if there's a field note or laboratory pass and fail, and then make comments, any of the comments, tracking how they're bounded, what reasons you took the samples for, so you have a quick reference and you can have all the information right there. You can identify trends, makes it a lot easier. And you can put all that information nowadays electronically. So I mentioned earlier, we're going to talk about a thorough review of laboratory results. It's not often not required, but I learned at the Palo Verde job that I talked to you about, we always had 3 people review the destruct reports that come in from the laboratory. And there were instances where one of us caught something the others missed, and it happened to everybody. I missed stuff, The junior engineer missed stuff and the project manager missed stuff. So, having three sets of eyes on a project, I think, is worth the money, especially. I think most owners would agree. They may not want to see, the bill, but if you have somebody only spending a couple minutes here and there looking at it, it's worth the money to, catch something. Because we see it in our audits all the time. We do project audits for clients and regulators find that we find destructs in the paperwork that were failing and there's no tracking. They weren't even caught. The CQA team didn't catch them, and these projects are certified, they're approved. So what happens now? We shouldn't be seeing that stuff. It should have been dealt with. You will occasionally get results that aren't for your project. So just because something passes, you got 120 pounds on your peel test or something, that may not be 60 mil, it might be 80 mil or something. You gotta understand the material, see if something really looks out of whack. With electronic things, it's easier to see nowadays. Same thing with wrong brake codes. We're seeing where we get wrong brake codes. We don't know if they're coming from the laboratory. We've seen them ourselves from laboratories, but not a lot of our auditing is just a tabulated data, so we don't know if they typed it in wrong or what it is, but it should be caught by somebody. And shear elongation, it's supposed to be reported. One laboratory, major lab in the United States, doesn't report the elongation. Another one does. Talking to them both, they both swear by their procedures. So, you need to find that out ahead of time. And here's just an example of why I think the project that we were on, their analysis, the laboratory was wrong because we had the 80 mils. It needed a shear elongation of 50%, which is standard per the GRI GM19A. And then our reports came back as greater than 1,000% elongation. I called them up. I said, "Do you mean greater than 100? Do you mean greater than 50? No, greater than 1,000. They swear by it. But I don't see how it could be. It was a textured geomembrane. This is a sample here. It's got asperity height, so it's textured. And, elongation at break of the parent material is only 350%. So you will get some values that are higher. That's going to be found on the parent material. Might get them double, but to get them nearly triple, I don't think that's going to happen. But, the engineers said, okay, regulators said it was good. Everybody said it was good. I don't think it was correct. I mean, it might be a little thing, but you really want accurate results. Wrong brake codes. I briefly touched on this one before. Your SE1 is applicable to only shear. SE2 is applicable to only shear. We see results all the time when we're doing audits that are SE1 and SE2 are applicable to peel. And then vice versa. The SE3 is only peel, and you see it listed for shear results. It just doesn't make any sense. Where are these errors coming from? Are they coming from a lab? And if they're coming from the lab, it really kind of upsets your confidence in them, to say the least. Dealing with failures. This is another biggie, kind of a mind-boggling. This image here, I guess, kind of summarizes it. Was created by, we generated it by AI, I guess Gronk or whatever, Gronk. I guess it's not the football guy who's on all the commercials anymore, and it's not the beer drinking dude from Australia with Crocodile Dundee, but whatever that thing is called, generated this for us. And, you'd be surprised how many people don't know how to deal with failures. There's just all kinds of numerous ways of dealing with failures that make them disappear. They're not tracked properly, and, nobody holds them accountable. But I said in my career, and I put it down here, if all my samples passed, I wouldn't feel like I was doing my job correctly. I'd be wondering what I missed. And I've left jobs like that. All my samples passed. I'm like, I'm sure these can't all be good, but yet they all passed. Well, kind of figure out now that some of the reason for that is they're melting the crap out of the liner and ruining it in the process. But hey, they're passing their destructive samples, and the welding technicians are getting their bonuses, but the owner is going to have issues in their wallet someday, probably because of some of that. And, it's frustrating. So anyway, enough about that rabbit hole. I'll start ranting and blowing up like that big bird here. Um, dealing with failures incorrectly. Some of the things we've seen, I mentioned the tracking, you're untextured, textured, it goes to a smooth. Nobody thinks about another textured seam. But we see, people stop at a passing trial wall, they stop at a passing end coupon. They stop at the end of a layer like primary. We're not gonna track back onto secondary because it's only secondary, and it doesn't make any sense. Stop tracking at the beginning and end of a shift. We've seen all of those, and really the best way to ensure you're getting the quality is to track back and make sure your samples are bounded. I've seen every one of these examples here where we've had failures. Same with this last one too, where the machine and operator are removed and then they may be brought back in at some point. Nobody takes a sample on them. But I track it and I've taken samples and I've found that they fail again when they come back. It might be a month, might be 2 months later on a big project. You got to keep track of that stuff and make sure that you're on top of it. No, the industry standard, I wanted to throw this in here just for reference. Most of you, I'm sure, know, but typically your failure is going to be bounded by samples in either the before welding, chronologically, what was welded before, what was welded after. Seam's going to be repaired or replaced between the samples. I mentioned that it doesn't account for material interfaces. And I mentioned why I believe, the textured smooth, and textured different thicknesses. You're going to have different settings on your machines, and you're going to have different levels of cleanliness and efforts that are required to weld them. It's just harder to weld. So I wanted to give you a couple examples here, failure scenarios. So this first one, a destruct fails on panel 6, panel 7. So that's this black star circled here. Assume this whole seam fails. The installer decides, hey, I'm just going to cap that seam. You would take your after sequentially here at this location if you look at those seaming logs. And then likewise, going before, you take it at the end of the seam 4-6 where it's marked. But so that would be how you would track it. But again, those are both on smooth. Nobody's considering any other textured interfaces that he might have welded that day or future days. If you look at the seaming, the blue guy, so he seamed this other color here, yellowish color, goldish color next. So seam 910 would be another one I definitely want to look at with at least end coupons. Might not put a destruct there because it's on a slope, but I'd want to know, the quality of it verified somehow. Excuse me. Failure scenario on 4-3. This one fails. So, okay, the sample fails there. They decide to cap everything that the guy welded because he only welded 50 feet. They knew he had issues. He switched machines. Well, nothing's saying you need to take a sample right after that, but I would take a sample on the first seam that the guy welded with the next machine just to get a confidence level with them because I've been on projects where we've audited and we've seen every machine the guy picked up, he failed. And so you want to catch it before they get on with a lot of other seam. You want to mitigate the damage if there is a problem. Some of the things we've seen, I'm going to go back and forth between slides here just real quick. But instead, remove the seam, you shift the panel over, or you remove it and cap it. So if that's the case, we've seen this on projects. Engineers have had us do it. Like say seam 6, 7, that fails, will be directed. Okay, they cut that out. So there's no destruct, there's no failure. They won't track it anywhere. They'll say, okay, the seam didn't exist. There's no failure. It's kind of mind-boggling, but it happens. Repair a seam to the end, disregard any before and after seaming. We've seen where, I mentioned they cap all that one has done, but they don't track it for that day beyond that day. Cap everything again, the guy comes back or the machine comes back. But then extrusion welding, when you do take them on patches, a big issue is that people will not track onto the smaller patches or not repair the smaller patches, but often those smaller patches are harder to weld than the bigger patches. So we're getting to where I can make you some recommendations here on your sampling protocols, developing a sampling protocol that, includes testing for the welding combinations, minimum testing frequencies. Make sure you have your material interfaces covered. Consider testing on the repairs for the reasons that I mentioned. End coupons are only as valuable as your CQA, really. Make sure that they're not cheating as they come to the end, and then, monitor the testing by the CQA firm if you want any value out of them. And again, have flexible locations. When it comes to the samples, get them right away. We were on a big project. I had like 20, 25 samples because they were in blackout mode and everything. We cut them, tested them, finally got them tested. I go back to get them, they're gone. Well, somebody had cleaned up and they were all in the dumpster. Luckily, the installer found them, but yeah, stuff happens. You don't want them blowing away. You don't want to cut more holes in the liner. We talked about the cheating and the importance of the chain of custody. Um, Choose your locations wisely. Again, use all the data available to determine the best location for the sample. You want to get something, if you're going to cut a hole, get something out of it, something of value rather than just creating a hole. But avoid high stress areas. Ensure your interface types are accounted for, and consider your extrusion. And these are areas that, have a higher probability of concern. These are areas I like to make sure are tested. Textured interfaces, immediately after burnouts, wheel spins, anytime you have dirt, paint, chalk, or debris in the seam, especially in bentonite, that can propagate for seams, if the machine isn't cleaned properly. Right before holidays, weekend breaks, people tend to relax a bit. Immediately after welding through cross seams with your fusion. Same thing with the cross seams if they're grinding or anywhere they grind to reduce the sheet thickness so they can fusion weld it better. And then any area deep grinding, exposed grind with extrusion is likely going to have issues. And the installer always should be given the option, to repair an area rather than take a destructive sample there. But again, you got to weigh that too. The installer starts putting 10 repairs on a seam saying, hey, I'm being proactive here. You might want to sample the seam and figure out what's going on there just to verify it. But, there's got to be a balance there. But repair rather than cut a hole is better, in my opinion, in most circumstances. Again, timely marking, wait until after non-destructive testing if you can. We talked about the timely sampling and timely shipping. For your review, this is often overlooked, is develop a review and approval protocol, multiple people looking at it, timely review. It doesn't do anybody any good if you get results Friday morning and we don't find out about them until Saturday afternoon or Monday morning because you're on vacation. There has to be a protocol that addresses it and gets the information in the hands of people right away. Continuously update the data, look for trends. I can't preach that enough. We find a lot of things by looking at the data, and it's important to keep an eye on the quality of your project through the data. Likewise, ensure protocols for the ASTMs are followed, especially by different laboratories. And in the field, there may be variables there or variants from that. Bounding, again, make sure you have proper sequencing. Check your seaming log. I have put them on the wrong seam on occasion, and we just have to deal with it, maybe reduce spacing on the next one or something, I don't like it to happen, but sometimes things like that happen. Consider your interfaces. Ensure samples are bound with passing samples. Again, the repairs of the area. I know I'm running out of time here. I'm really on my last slide for this thing. So, but ensure all the areas between failing samples are bounded. We see this in our audits all the time where you got Destruct 25A2 or something. It's sitting out there all by itself. Look down the seam, 20 feet down the seam might be A1. There's no weld between them. And, we've seen it where like A2 is sitting there right next to textile or composite. They've placed material, they're covering it up, and there's no repair to the seam. That's not doing anybody any good either if you're finding a problem and not fixing it. So, and then I always say consider fusion welding for the bounding of your repairs instead of extrusion welding. If you have a failure, you're going to be at least 20 foot in each or 20 foot total, 10 feet in each direction. You can weld 40 feet of fusion weld, and it's better than 40 feet of extrusion weld. Um, so that really concludes my rant on Destructs today. Sorry, I got a little rabbit hole there. I got worked up on some of this stuff, but next one's going to be April 17th. So mark your calendars, Thursday, April 17th, 12:30 p.m. Eastern. April Fools, misconceptions, misunderstandings, and foolishness that may sink your containment project. And it'll be an interesting webinar, I'm sure. I got to figure out how to pare it down from about a week's worth of material to an hour, but there's a lot I can rant on there. So I hope you tune in for it. And let me see if I can get to questions and answers for a minute here, a couple minutes if we have any. I'm gonna try and get to that. Yeah, see if I can do it without hanging up on everybody. Yeah, I don't see any open questions at this point. So, again, I appreciate you all for tuning in. I hope you learned something new today. I appreciate you tuning in and listening to me once a month. And yeah, I enjoy doing this and looking forward to next month. So until next month, take care and I'll see you then. Thank you.